All right, so if you are watching this video, this one focus on distance while braking. If you have not already created your diagram, programmed your distance while distracted, and your distance while reacting, go back and do those steps first before continuing with this video. If you're ready to move on, then let's continue. I'm gonna scroll down to my distance while braking. All right, and then I'm going to click B19 right under the line that says distance while braking. As you can see that this chunk is a little bit bigger than the other ones because there's more steps to it. Some of the equations are a little bit more difficult, so you want to make sure that you are taking your time with programming this specific spot. So the first piece that I'm going to need for this is my velocity of the car before braking. All right. And I'm going to slide over to C19 and I'm going to change that to green to match my other columns or rows. And then my units for velocity is meters per second. I am going to skip a line and go to B21. And I'm also going to type in velocity of the car after braking. So I need to know the velocity of the car before braking and after braking. Slide over to C21, change that color to green, and then slide over one to D21 and put in my units, which is meters per second. After I do that, I am going to skip a line again, go down to B23, and what I'm going to type here is deceleration of the car, because I need to know my deceleration rate, so the rate the car is slowing down, to help me factor in to figure out the distance. I'm going to slide over to C23. Once again, change the color to green. Slide over to D23 and put my units, which is not meters per second, but meters per second because this is acceleration. It's just a negative value for acceleration, but same unit for acceleration. After I have that, I'm going to skip a line once again, and I'm going to do time of braking. This is in B25. Okay. What's nice is if your cells match up to this video or mine, then it's easier to program the different equations. So go back and double check that if you need to. Just be cognizant that if your cells do not match up to mine, that when you are programming your different equations, they might turn out a little bit differently. You got to click on your specific cells. All right. So time of braking is not an inputted value. I actually need to calculate that. So I'm not going to go into the C column. Instead, I'm going into the D column, which up top says needed calculations. This is the only one that we had that is actually in that column that is not a unit. That's actually a needed calculation. So D25, once again, as you can see from the top, the color code for that one is yellow. So I'm going to switch that to yellow. And then afterwards, I'm going to type in my equation or my programming to figure out time of braking. So time of braking is equal to or equals final velocity minus initial velocity divided by acceleration. I want to make sure that I'm programming this correctly. So equals. So my final velocity, which is my velocity after braking, C21, because that's where I'm going to put that value, minus C19. Okay, so that's final velocity minus initial velocity divided by acceleration, which is C23. Once that is done, make sure you do not touch or click anything besides the enter button. All right, so that spot is now calculated for me, or programmed for me specifically. The last piece of the puzzle for this chunk is to actually figure out the distance. So distance while braking. Okay, just following the same color code as I did up top, changing that cell color. Oops, that's a little dark. Okay, so this is in B27. That's where I just wrote distance while braking. since this is my last needed output or calculation, I'm going to go over to E27. I'm going to change that color to red to match my other ones. Okay. Before I do that programming, I'm going to put in my units so I don't forget, which is meters. And then I'm going to go back into the E27 and I'm going to start my programming. So this cell, the equation is a little bit more difficult than the other ones. It's not a simple one. So remember, distance of braking is equal to 1/2 times acceleration, or 1/2 acceleration times time squared plus velocity or initial velocity times time. So if I am talking about this as an equation, I'm going to go over here real quick. I have distance of braking, oops, ignore that. Distance of braking is equal to 1/2 acceleration times time squared plus my initial velocity times time. So I'm just going to leave that there so I can remember this is the equation that I'm using. I'm going to go back into my E27 cell and I'm going to type in the equal. I don't need the D for distance in that because that's over here. So 1/2, I'm going to represent 1/2 with 0.5 just because that's a little bit easier, times acceleration, which is C23, making sure that I'm clicking the right cells. I'm going to close that parentheses, and then I'm going to multiply that by time, which is this column, D25. And I need to square this. So to get this caret to show squaring, I'm going to do Shift 6, gives me the caret, type in 2 for squared, plus my initial velocity, which is velocity of the car before braking, C19, multiplied, so Shift 8, time. So here, this equation is represented like this in the cells: 1/2 times acceleration times t squared, which is time squared, plus initial velocity times time. Once that is done, make sure you do not click anything else. Click enter. And if you got something like this, that means you programmed it correctly. The error message is only because I don't have anything written in. So if I want to make sure these are programmed correctly, I can go ahead and put values in just to double test it or double check it. So let's say my initial velocity was 10. After braking, let's say it went half. Okay. Standard rate of a deceleration is -8, and boom. That's how I know I programmed it correctly.